Hello, welcome back to the lecture series on network layer part 2 of the internet model. In this video, we are going to learn about multicast routing algorithms. So what is the agenda? I will introduce you to multicast routing algorithms. After that, various applications of multicasting. Then overview of several multicast routing algorithms will be discussed. So let me introduce you to multicasting. But before that, we must know what is unicasting, broadcasting, and then we go to multicasting. So what is unicasting? Unicasting means one-to-one communication. There is a single source and a single destination, and packets are forwarded from the source to the destination. This is also called peer-to-peer communication. Let us look at this example. Here we have a source S1 and a destination D1, and in between there are several routers 1, 2, 3, 4, 5, 6. Now the source wants to send a packet to the destination. The source S1 is sending a packet to destination D1. So it starts with a single packet having the source address and the destination address. This packet moves to the router, the first router R1. From this router, after going through the optimum path, it suggests that it has to go to router R2. From router R2, it goes to router R5 and then to router R6 and then to final destination. So there is a single packet moving from the source to the destination through the optimum path. In multicasting, there is a single source, and suppose there are many destinations, let's say D1, D2, D3, D4, D5, which are connected. Now we can create a group of, let's say, 3 destinations and can create a multicast group. So the source will send packet to this group address, and whoever the destination is inside the group will be getting the information. So this is one-to-many communication. Let's understand this with the help of this network. We have a source S1 and there is a group address G1. Under this group address, there may be several destinations. So if the packet is sent from the source to the group address, all the destinations who are inside the group will be getting the information. So the source starts with a packet P having the source address and the destination address as the group address. This is called the multicasting group address. It goes to this router, let's say R1, and this packet is sent particularly to these groups. Let's say to this group there is one host, to this group there is another host. Like this, all the packets will be distributed to the particular group and finally to the destination through the nodes of the network. Next, we understand the concept of multiple unicasting. This is an example of multiple unicasting. In multiple unicasting, there is a single source but several destinations D1, D2, D3, D4 and D5. Here the source starts with, let's say it has to send packets to all the 5 destinations. So it starts with 5 packets. And when it comes to this router R1, it understands that this packet is destined to D1. It sends this packet to D1. Then we are left with 4 packets. The 4 packets come to router R2, and then the packet which is destined to D2 is sent to D2. We are left with 3 packets are there. 1 packet comes here and the other 2 packets go here. It is sent to, let's say, this router R3. From this router R3, these 2 packets go to this router R4. From router R4, 1 packet comes to destination D5 and the other packet goes to destination D4. Here, this packet from R2, one goes to D2 and the other one goes to this router. Let's say this is router R5. From R5, this packet basically goes to D3. So there is a basic difference between multiple unicasting and multicasting. In multiple unicasting, the source starts with all the 5 packets, and these packets are destined to different destinations. But in multicasting, the source starts with a single packet which is replicated for each of the destination in the group. Next we go to broadcasting. Broadcasting means there is a single source and all other hosts which are connected to this source will be able to get the information. So this starts like this. So this is called one-to-all communication. So all the nodes which are connected to the source will be getting the information. So this is basically the example. We have a source S1 and there are 4 destinations D1, D2, D3 and D4. If the source starts with a single packet, it moves to all the destinations at the same time. There are various applications of multicasting, like access to a distributed database. Nowadays, database is distributed in nature, meaning that the entire database is not situated in one location. Rather it is situated in several locations, location 1, 2, 3 and 4, etc. So if it wants to get the entire database, the source will call for all the parts of the database from the distributed locations. Then transmission of information is again one important application of multicasting. For example, if college authority wants to send this information that the exam is going to start on such and such date, it can give it to a group of students. Let's say it is to the 4th year students. So the 4th year student is a group, and to that group, if the college authority sends the information, it is received by all the students in that group. Similarly, sharing of news is again another multicasting application, where if a group of people, if it wants to get some news, they basically belong to a particular group, and the sharing of news can be done within that particular group. Distance learning is very important nowadays, and distance learning basically is one to a group of students S1, S2, S3, S4, and here there is an instructor. So instructor can give a distance learning instruction by any of the virtual learning platform, like Zoom or Google Meet or any other online learning platform, where the instructor gives instruction, and all the students who are actually logged in to that particular invitation login platform get the information. Then teleconferencing is also one important application of multicasting, because in teleconferencing, all the people who wants to do teleconferencing must be attached to a group address. Next we go to optimal routing. We have already learned about the meaning of optimum path in a previous video. Optimum path means the best possible path which a router must adopt to forward the data packets from the source to the destination based on several metrics like cost, like hop count, like throughput or delay, etc. In order to do optimal routing, we create shortest path trees. Shortest path trees means there is a root node, which is basically the source, and from the root node there may be several shortest path trees which can lead to several destinations D1, D2, etc. Now, this shortest path trees for unicast routing is different from that of multicast routing. Let us understand the optimal routing using shortest path tree for unicast routing. Let's say we have this network where there is a root node, and we have to create the shortest path trees to all other networks. We have 6 networks here, 1, 2, 3, 4, 5 and 6, and we have 1, 2, 3, 4 routers here. Let's see how to create the routing table. Each router will have a routing table, and each routing table will indicate a shortest path tree. Let's understand that of router R1. So this router R1 will create a shortest path tree of itself. So in order to do that, we have the destination field and the next hop field. Each row will be a shortest path, and the entire table will be a shortest path tree. So we can see here, if from this router we want to go to the network N1, it is a direct connection, so there is no next hop. If it wants to go to network N2, then the next hop is R2. If it wants to go to network N3, then also the next hop is R2. If it wants to go to network N4, then also the next hop is R2. If it wants to go to network N5, it is a direct connection, so there is no next hop. And if it wants to go to network N6, then the next hop is router R4. So each router in this domain will have a table that will define a shortest path tree to possible destinations. Next, let us consider shortest path trees for multicast routing. Now, in multicast routing, there is a term which is known as source-based tree and group-based tree. Let us understand what a source-based tree is all about. As before, we have this network. Here, instead of the destinations or the networks, we have the group addresses: G1, G2, G3, G4 and G5. And there are 4 routers: R1, R2, R3 and R4. Now, as before, let us consider the routing table of R1. Here, each row will be a shortest path tree. Unlike that of unicast routing, where each row was a shortest path and the entire table was a shortest path tree, but here each row is a shortest path tree. So the table router R1 will have here, for this example, 5 shortest path trees. Let's see this. If you want to go from router R1 to G1, then there are how many possible paths, or what is the next hop? You can directly go there. So this is a dash here. You can go via this router R2 to reach this G1, or you can even go via this router R4 to reach G1. Similarly, if you want to go to the group G2, it can be either direct connection or it can go via this router R2. If you want to go to G3, then you can directly go, because this is a direct connection, and again you can go via router R2. If you want to go to G4, then either you can go via R2, because here the G4 is here via R2, and again you can go via R4 because G4 is also here. If you want to go to G5 from R1, you can either go via R2 because G5 is here, and again if you can directly go to G5 here via R4. So each router involved here needs to construct a shortest path tree for the group. Now, for source-based tree approach, each router needs to have one shortest path tree for each of these groups. Let's now see the multicast routing shortest path trees for group shared tree. Let's again construct a network, but here we have a core router. This core router is basically responsible for forwarding the packets to the different groups. So let's look at this routing table. This is basically the routing table of core router. So if the destination is G1, the next hop will be R2, R3, R4 and dash. So it is R2, R3, R4 and it is also directly connected to G1, so the core router, so we can give a dash here. If it wants to go to G2, again, it can go via R2, or it can go via R3, or it can directly go to G2. If the core router wants to go to G3, it can directly go, because G3 is directly connected to the core router, because core router is connected to all the groups. If it wants to go to G4, then it can go via R3, it can go via R3, or it can go via R4. And for G5, it can go via R4. So we have here 5 shortest path trees. So in this group shared tree approach, only the core router will have the shortest path tree for each group that is involved in multicasting. Let us now look into the taxonomy of multicast routing protocols. Now, multicast routing protocols, as we have seen in the previous slides, it is source-based tree or group shared tree, and this tree is the shortest path tree that is formed. In source-based tree, we can have MOSF or DVMRP. Now, what is MOSF and DVMRP? MOSF is based on the multicast link state routing, and it is known as the multicast open shortest path first. DVMRP is distance vector multicast routing protocol, and it is based on multicast distance vector routing. For group shared tree, we have PIM, which is known as protocol independent multicast, or we can have CBT, which is known as the core based tree. Now, PIM can again be PIM DM or PIM SM. PIM DM is protocol independent multicast in the dense mode. Dense mode means dense multicast environment, as for example we have in LAN. And SM stands for sparse multicast environment that we have in WAN. To summarize, in this video we have introduced the readers to multicast routing algorithms, but before that we understood the difference between unicast, multicast and broadcast. We understood the different applications of multicasting. After that, taxonomy of various multicast routing protocols like MOSPF, DVMRP, CBT, PIM. Thank you.